So my tree is created. Now what I will do, I will go to my tree traversals. Now here I want to create a function. I want to create a method. That method will not return anything, that is void. Okay, the name, let's say preorder traversal. Okay, so it is very simple, preorder traversal, self-explanatory. Next we will go and create the argument, node, type of argument, and node. Fine. So what this will store, this will store initially the root. This will store initially the root. Now if my node is pointing to null, so what will happen if my node will pointing to null? So if my node is pointing to null, I said return. I have just, when I have explained to the tree, what will happen if my node is equal to null? Just return nothing, but just return. Okay, wherever you came from, return there. Okay, return to your parent if my node is null. Now if my node is not null, then what will happen? Now let's see here that this is my tree, this is my preorder traversal, and the first statement is print the node I am talking about. So in the beginning I will pass root, correct? So the node I am talking about is nothing but 1. So if I print it, so the first thing that will be printed is 1, and that is what I want. Now the second line is go to the left. So call the function again for the left node. Call this function, same function again, that is preorder traversal for the next node. Okay, we will be performing preorder traversal for this, then we will perform preorder traversal for this. Okay, and for this for every node we have to perform preorder traversal. So for every node this function will be called separately. Fine. So when I come here, the first thing that I will see is print node. So it will print me 2. I have explained you this. So we have 3 steps. First step is printing the node. Second step is calling the function for the left side tree, and the third step is calling the same function for the right side tree. Okay, these are my 3 steps, and my code is over. So this is that simple. I will explain you in the recursion concepts also using the stack, but this is this simple. First is system.out.println. See, we have to print it. What we have to print? We have to print the data inside my node. So the node.data and just a little bit of space. So plus for the next node. Fine. This is I am printing. What is the second one? You know what is the second step? Second step is call the same function. This time the node will be left side of the node. Okay, left side of the root. So call the same function preorder traversal and pass the left side of the root. Fine. So node.left. My node was pointing to root in the beginning, so node.left. Correct. So if I am here and I want to pass, now my node is pointing here. Correct. So now if I want to pass again, so I will pass node.left. What is node.left? 2 of left, which is 4. Correct. So the left side will be. So now what will happen? My node is at 1, so the left side is 2. So this function will be called for the left side. Now when the left side is completed, then what I want to do, that is the third step, call the right side. So that's why this is the code. This is over. No, if you want I can show you. Just I will print it, and after that I will explain the recursion concept after I am printing it. Okay, so from the main method I will call the tree traversal method. So system.out.println, what I will do, preorder traversal is it's very simple. What I am to do, I want to call it tree dot preorder traversal. So tree is my reference variable for the class tree traversal. So if I want to access any method of the class tree traversal, I have to use this reference variable. So tree dot, and what I will pass tree dot root. Okay, so root is also what a variable of tree traversal class, as you can see here. So to access it I have to write tree. Okay, do not directly write root, it will give you an error. See, it gives you an error, cannot find the symbol. Okay, so tree dot root. So I passed my root. So if I now run it, if I run the program, it will simply print the preorder traversal for the tree. And we have seen what the preorder traversal for the tree is. First 1 will be printed, as you can see, 1 2 4 5 3 6 and 7. This is my preorder traversal. You can check it. Okay, and if you want to print this into a single line, what you have to do is simply don't use ln, just use print. And now when I run the same code, what I will see is this is printed on the same line. So 1 2 4 5 3 6 and 7. As you can see, this is my preorder traversal. Now how it ran, just think about it. If you know how recursion is implemented, because if you're learning tree, you have seen recursion videos, correct? So what I want you to do is, just for a moment take pen and paper out and draw the recursion tree, draw the recursion stack. Correct? So once you have drawn the recursion stack, you have completely understood this concept. Okay, this is so simple, this 3 to 4 lines of code, and we have printed pre-order traversal. Everything is working behind the scene. Okay, once I am doing the recursion, everything is working there. So just try. I will now, I am going to show you the recursion stack for this. Now let me show you the recursion stack for this. Correct? So what I am passing in the so root equals to 1. This is what I am passing. Correct? So now the node value becomes 1. In the beginning the node value becomes 1, that is node.data is 1. Node is pointing to the node is my reference variable, and it is simply pointing to the root, and its data value is 1. Okay, so directly I am saying that node is pointing to 1. Okay, this is the terminology I will be using, so don't get confused. So what it is, now I have passed root, so the node value is 1. Okay, so now this is my first one, so this is simply called, that is pre-order traversal is called. Correct? My node value is 1 currently, so node is not equal to null, no issue, and these are my 3 steps. So 1, 2 and 3 are my 3 steps. So the first step is printing it. Print 1. So 1 will be printed, so this here is my answer, 1 is printed. Second is call left of 1. So left of 1. So what is left of 1? Just think, what is left of 1? 2. Correct? So the left of 1 is nothing but the node with data value as 2. Okay, so go to the left. Okay, node dot left. Correct? So when I go to the node dot left, the same function will be called again the second time. This was the first time it was called, now it will be called again the second time. Okay, now my node value for this function became 2. First step is print. So print 2. So 2 will be printed, not an issue. Now the second step is call left. Now what is 2 of left? 2 of left is 4. So call with 4. Now the node value for the third one will become what? Now what is passed in this same function? It is 4 that is passed. So node value will become 4. First is print. So it will print 4. So 1, 2 and 4. Next is call left. Now we will call left with null. Now as you can see here, when we call left with null, so the node value will become null, and when the node value becomes null, it will return. So as we know, if I show you, this is the fourth one, node value was null and it will return. So where a function returns, function always returns to the calling point. So the function will now return here. That is, the calling point for this function was this calling statement. Correct? So it will return here, and it will say that I am returning because I am null. So after the second step is over, we will finally move to the third step. The third step is calling right. Okay, now it will call right. Now right is also null, so the left is also null and right is also null. So right will be called and node value will become null, and it will return. As you can see here, whenever the node value is null, it will return. So where it returns, it always returns to the calling point. So for node equals to 4, that means for this node we have performed all our 3 operations. That is the first step, that is printing 4, it is done. Calling the left one, it is also done, and calling the right one, it is also done. Since all the 3 functions are performed, now it will return. Where it will return? Wherever this 3 was called from, this recursion stack was called from. Correct? Recursion function was called from, so it was called from here. When I passed left equals to 4 there, then it went here. Correct? So it will return me here. So for node equals to 2, the first step is over, the second step is over. Now the only thing left is the last step, that is calling right. Now when I call right, so it will simply call right with value as 5. Okay, so this is done. So now I'm calling this. Now the sixth one will be called, and here node will become 5. So the first step that it will perform is print. Correct? So the first step it will perform is print. So it will print 5. The second step it is going to perform is call left. So now tell me what will happen. I have already explained this one. So 5 left is null, 5 right is also null. So when I call the left one with null, so the same thing here will happen. Now you know this. Now I don't have to explain this again. So it will come here and with the return value. Now first step is over, the second step is over. Now the right. It will call right with null. Since it is calling with null, it will return back with a null value. That is nothing. Return back with nothing. So the first step is over for node 5. The second step is also over for node 5, and the third step is also over for node 5. Since all the three steps are over for node 5, it will return back to its parent. It will return back to its parent, that is 2. So when it returns back to its parent, that is the calling point, and the parent it is with the node 2. So all the operations for node 2 is also over, that is printing 2, which is done, calling the left side, which is also done, calling the right side, which is also completed. Since all are completed, 2 will return back to its parent. So where it was called, where it will return at the calling point. So for 1, printing 1 is complete, that is the first part is complete. Going to the left is complete, going to the left is complete. Now it returns back. After performing all the operations on the left side, it returns back, and the third point will now be executed, that is nothing but calling the right side, with a value of node, that is 3, with a value of node, that is 3. Now what I want you to do is write the recursion stack. Now you can do it. Now I have explained you what will happen when node value was 2. When this was called, I have explained you what will happen, correct? So now tell me what will happen when the value of 3 is called. The same will execute, first the print, second the left, then the right. Okay, this same things will execute, and I will finally get my, after 5 I will get 3, 6 and 7 as my answer. Okay, so 1 2 4 5 3 6 7 is my answer. As you can see 1 2 4 5 3 6 7 is my answer. So this was recursion stack, correct? And this, you can assume this is a recursion tree. First we are calling with 1, then the function calls to the left, so it will go here, then here, then here, then here, then here, then here. So I have completed it. Fine. So this was preorder. What we have done in preorder is I have explained you the recursion stack, how it will work. Now you have to do the recursion stack for right equals to 3 when I do this. Okay, just see this part, explanation part again. What happens in a recursion stack? Fine. When the left function was called, as you can see here, when the left function is called, what it will pass? It will pass node dot left, node dot left. So what was the node dot left for 1? It was 2. So 2 was passed. As you can see, node value became 2. For 2, when left was passed, node became 4, as you can see. For 2, when right was passed, node became 5, as you can see. Okay, so 2's right is 5, 2's left is 4. This is very trivial. Fine, I am explaining this in very detail. This is very trivial. Okay, so 3 will go to its left, 3 will go to its right. So 6 and 7 are the answers. So you have to draw the recursion stack for this. But this is my code. This is my code. This is a very simple code. I have explained you the recursion behind it. Okay, if you want, I can show you the recursion here also. I can show you the recursion here too. Let me show you the recursion here too. Okay, what I will show you is how these values are passed one by one. One second, it is just loading. So as you can see here, the preorder traversal is, and just focus on this. So now my node value is with data equals to 1, correct? In the beginning, the node value was with data equals to 1. I move forward, node is not equal to null, so it will not return, and it will print me a 1. So as you can see, it prints me a 1. So first step is over. Yay. Now the next one. So what is the next one? Calling the left side. So what was the left side? Left side was nothing but 2. What was the left side? As you can see, the left side of data value 1 is nothing but data value 2, and we have seen it. So one left side is 2. Okay, now this value will be passed to the same function again. As you can see, it passed to the same function again. Now node value became 2. For it, the left side is 4. Okay, and again it will print 2. Now it will print 2. So 1 and 2 are printed, and now it will call with the left side of 2. So what is the left side of 2? Left side of 2 is nothing but 4. So it will call with data value equals to 4, and as you can see here, now the data value became 4, and the left side is null and the right side is null. As you can see here also, the left side is null and the right side is null, correct? Now data value was 4, so it will print me a simply 4. So as you can see at the console, 1 2 and 4 are printed, correct? Now what will happen? It will go to its left side, but the left side is null. Since it is null, it will return. Since it is null, it will simply return. As you can see, node.right is null. Okay, so it will return me. After returning, it will go to the right side. What I have explained you, same things are happening. When n was null, it will return me. After returning, it will go to the right side and it will call, okay, and here also it will return back, and here also it will return simply me a back. As you can see, this returns back. When it returns back, for the node 4, all the functions are over. For the node equals to 4, as you can see here, the node is 4, all the functions are over. It will go back to its parent, that is node value 2. Now let's see the magic. Now it will go back with the node value equals to 2. As you can see, the node value now data is equals to 2. Yes, yes. Now what it will go, now 2, what happens here in 2 is, it's very simple. That node value is 2, it printed 2, it went to the left side of 2, now it has to go to the right side of 2. Therefore you can see this one is highlighted, because now we are going to the right side of 2, correct? So when we go to the right side of 2, what is right side of 2? That is data is equals to 5. So now my new data value will become 5. Left is null, right is null, and the same function will go over and over again till my all values are printed. Same function will run over and over again till my all values are printed. So as you can see here, 1 2 3 5 3 6 7 is printed, and finally it will simply stop. As you can see, it came back to my main function where this function was called, and it will stop. So 1 2 4 5 3 6 7, this was the preorder code. Okay, so what we learned in preorder is, if the node value is null, it will return. It is common in everyone. First we will print, second we will call the left side, third we will call the right side, correct? So what will happen in order is, first left, then print, then go to the right, correct? So what we have seen till now is, in preorder, first is the print step, second is the left step, and third is the right step. But what happens in inorder? Just tell me what happens in inorder. I have explained you what happens in inorder. Okay, using that knowledge, you have to write now this code. That is also a 3-line code. For post order also I have explained you, that is also a 3-line code. Fine. So pause the video, just write the code. Okay, draw their recursion stack also. You will understand it really better. This tree is a very important concept, and in this tree concept, recursion is used almost everywhere. So you will also understand recursion here. Fine. So what you have to do, you have to draw the recursion stack for in order and post order, also write the code for it. Fine. After writing these two things, then come back to the video and I will show you the code for in order and post order, and just match the code. Okay, there are also 3-line codes. So please pause the video before moving forward. Okay, and write the code for yourself. Now I really hope that you have paused the video, what I have told you, you have done that. Okay, I really hope, because now I'm going to write the inorder traversal and postorder traversal. Now I wanted you to write this. Okay, I hope you have written this, and you are here only for checking it out. Is your code correct or not? Fine. So void inorder, because it will not return anything, therefore void traversal and node. Fine. And I have explained inorder also, so that is not an issue. What you have to do, you have to draw the recursion tree of it. If you haven't written the code, at least draw the recursion tree after seeing the code. Okay, just like we did in preorder, just do the same things. Now what happens in order is, first we will call the left side. So in order not dot left, correct? After we call the left side and everything is over, then we will print my node dot data. Okay, after this is done, I will call my right side. So node dot right. Fine. I have explained. Yeah, code is done. This was this small. I've told you this was a 3-line code, and same things for post order also. Same for post order. I told you this was this simple, correct? So what we did, we first went to the left side, we printed everything on the left side, then we printed our root, correct? So left, printing the root, going to right. This is in order. We have learned this in order in colleges also, in the lectures also, on your course. So in order, what is in order is, first left, then the root, and then the right. Done, complete. Now at least write the post order code, pausing the video if you haven't written it before. So post order traversal. If you have written it before, that is great. That is really good. You should have written it. Okay, that is really good if you have written the code. Fine. So what is post order traversal? So if node equal to null, just return nothing. Okay, just return back to the parent. Now first call the left side in post order. After that, call the right side in post order. In order node dot right. fine, and after that print it. After that print the data. So first call the left side, then call the right side, then print the root. This is what post order is, correct? Now just do the recursion stack for this one also. Do the recursion stack. If you do not do the recursion stack, you will not be able to understand this. Okay, recursion stack is very important for this question. Recursion is very important for trees, fine, because next we will be seeing the height of the tree, the size of the tree, also we will be seeing the level of the traversal for the tree, and all these things require recursion a lot. So please see the recursion stack video again. Okay, the part where I explain the recursion stack, see that part again, fine, and complete that. I haven't completed it because I want you to complete it. Okay, I have completed the left side of the tree. You have to complete the right side of the tree for pre-order, and to the whole left and right for in order and post order. Okay, now what I am to do is simply go to my main function and call these two functions. So system.out.println post order, first in order. So in order traversal is simply on the next line. Let's do on the next line. Is simply tree dot in order traversal and pass me the root. Pass the root. This is done, and the same thing you have to do for the post order traversal also. The same thing, nothing else. Okay, post order. Let's see what it will print. So you know the answers. If you don't know the answers, just write it down the answers before seeing the result. Just write down your answers of in order and post order traversals and match them with the result. Okay, so this is now it is just running now, the in order traversal, the post order traversal, and the preorder traversal. Now again I have made the same mistake twice now, so do not use println if you want to see the result in a single line. Okay, do not use ln, just use the simple print, fine, and it will just show you the answer. So it is running again. So yes, now you can see that the preorder traversal is this, the in order traversal is this, and the post order traversal is this. Okay, now as you can see, it is not looking that nice. So what you have to do is simply do a next line. Okay, so now when you do a next line between these two, this all will be printed in different lines. Now run it again. So this is nothing but I am just showing you correctly. So yes, now you can see preorder traversal is 1 2 4 5 3 6 7. Now the in order is 4 2 5 1 6 3 7, and the post order is 4 2 5 6 3 7 1. So now you can match your answers. What you have seen, you can draw different type of trees. This is not the only tree that you can draw. Okay, just change the values here and see different preorder, post order, in order traversals. Okay, draw the recursion tree for this, recursion stack for this, and it will be very clear. Okay, this is very easy recursion. Next we will see the height of the tree, the size of the tree, and also we will see the level of the traversal. But before that, I urge you to do those three. At least try to find the height of the tree, try to find the size of the tree. Okay, level order I will explain, but the height and size, they are really simple. You can really do this. Okay, you know how to go to left, you know how to go to right, fine. You can go to till leaf. Okay, you know how you can identify whether that is a leaf or not. If the left child and the right child both are null, then that is a leaf. Okay, we have identified this in this one also. So do those things. Okay, and in the next I will also explain. Definitely I will explain, and just cross check it. Cross checking gives more confidence. Okay, if the cross checking is right, it gives more confidence, and if it is wrong, at least there is a satisfaction that you have tried. Okay, but if you go to the next video without trying, you will not feel complete. Okay, in simple words, you will not feel complete. So try, and after that come back to the next video. Fine, so I will be stopping here. Thank you.